So my talk today is about human-centered geospatial AI, understanding human multisensory environmental perceptions. So before I talk about my my work, I just want to elaborate a little bit more about my past background and give you more background of geography and what is geospatial AI. As you can see, I previously worked in both academia as well as industry companies. For instance, I got my PhD from the other UW, University of Wisconsin-Madison, and then I was a postdoc at the MIT Sensible City Lab, and I also had working experience at Google. So I define myself working at the intersection of geography, computer science, and urban planning. So before I delve into my research, my first question for you is, in your opinion, what is geography? What is geography? Think about some keywords, think about your impressions of geography. What is geography? My past work is about human-centered geospatial data science, focusing on geography as well as the human dimensions of geospatial data science. In particularly, my work focusing on two missions. One is to understand human experiences, subjective experiences at different places, such as your perceptions, emotions, cognitions, and even creativity. These subjective experiences, because we think only our human have the emotions, have the perceptions, and how they related with geography, with locations, with places. The other mission is to develop trustworthy and ethical GIS technology, such as mitigating bias, protect human geo-privacy, enhance explainability of GeoAI, and building inclusive GeoAI. So again, probably you're coming from different domains. You may not from geography. So back to my first question, what is geography in your opinion? I first want to give you a sense of what is geospatial data. What is geospatial big data? You might be using different forms of data, such as those texts, such as those images. As geographers, we are also interested in that, but we are more interested in geography, location-related data. For instance, you might be familiar with these different types of geospatial big data. You may have posted messages on social media platforms, such as on tweets. You may add geotags. All of your mobile phones are equipped with GPS, and your vehicles are equipped with GPS, right? So with this GPS, we can now observe and even track human mobility and trajectory to understand how people move, how vehicles move. In addition to this, we also have large volumes of geospatial image data, including remote sensing images, as well as street view images. Before I come to the UW, I also visited the Google Maps and opened the street view images and play around to have a better sense of your beautiful campus. Yeah, this is really a beautiful campus. So I believe all of you have played with some of this geospatial big data, right? So as geographers, we are curious about how can we leverage this geospatial big data to empower different society to benefit different real-world applications as well as practices. However, most of the prior studies focusing on the physical environment. When I ask you, what is geography? You probably think about the environment, those physical environment, right? Such as the water, such as the green space, the physical environment. But as human, when you visit different places, when you visit different locations, you have subjective experiences. For instance, in our people should be placed at the center of a location of a place. Geographic phenomena are always treated as functions of a set of physical settings. while lacking considerations of the human subjective experiences in prior spatial data science methods. For instance, Professor Yifu Tuan, who is a big name in geography, he mentioned that people think that geography is about capitals, landforms, and so on. But it is also about place, its emotional tone, its social meaning, and generative potential. And you are also fortunate because at UW, you have, at the Department of Geography, you have a humanistic GIS laboratory, which trying to bridge the gap between technology or GIS as well as the human geography. So here, my question is, can we enrich geospatial data science with human experience? So again, I want to ask you, what is your human experience at different places? For instance, for me, I'm not studying here. When I visit this campus, I have some feelings. For you, because you are the alumni, you are the students working here, studying here, you might have different feelings, you might have different emotions, perceptions of the campus compared with me, right? So that's how places influence your, so that's how the places influence your subjective experiences at different locations. And this is what we so-called a sense of place that denotes nebulous human meanings, such as subjective feelings and perceptions that evoke different emotions, experiences, and identities attached to the place. Let me ask you a simple question, very simple question. When you go back to your home, probably your house is very similar, have the similar settings of your neighbor's apartment, right? But why? When you go back to your home, you have a different meanings, you have a different emotions. Because you are familiar with your home, that is your home, right? Even if the house is the same as your neighbors, but you will not like that, right? Because that is not your home. So this is what we so-called the sense of place. Your emotional, your subjective feelings, how you perceive the location. This consists of our sense of place, the subjective experiences. So today, I will be talking about how we can use geospatial data science and AI to better understand such human subjective experiences or perceptions. I will be talking about two projects. The first one is understand human safety perceptions of neighborhood. And the second one is geo-contextual soundscape to landscape generation. Okay, after I talk about the sense of place, this concept, let's continue. I would like to give you a warm-up question. So look at these two images. Look at these two street view images. You might be familiar with these street view images because they were downloaded from Google in Seattle. In your opinion, which place looks safer, the left one or the right one? Yeah, go ahead. Left one? If you think left one looks safer, please raise your hand. If you think right one looks safer, please raise your hand. I think most of the people prefer the left one, but also there are some people like the right one. As you can see, your perceptions, people have different perceptions of the environment of the place. And also, your perceptions will influence your behaviors. Assume you are all millionaires. Assume you have a lot of money. You can purchase a house at any neighborhoods. I'm sure all of you want to live in a neighborhood that makes you feel safe, right? But then the question is, how can we measure such human subjective safety perceptions? How can we understand whether a neighborhood, whether a location is safe or not safe? So traditionally, to measure human perceptions of place, we rely on some methods such as self-reports, surveys, and mental maps. But you may know that they have some limitations, such as restricted to small-scale regions, they are labor-intensive, they are time-consuming. So that's why we need data science, we need AI, right? because they can supplement these traditional approaches. Are there better ways to measure human safety perceptions of a neighborhood? So we propose to leverage spatial data science methods that combining trivial images and deep learning approaches to measure human subjective safety perceptions. So here is a computational workflow to measure human safety perception. I believe you are more familiar with these two sample images at UW than me, right? You are more familiar with these two, right? So the hypothesis is your participant perceptions, like your participants of trivial images, are treated as a proxy of your perceptions of the built environment. So if we can collect and understand human safety perceptions towards the trivial images, and then we probably can train an AI to understand and to modeling human subjective safety perceptions of the neighborhood. So later, we collected some human perceptions of place data by setting up a survey in Stockholm, Sweden. We asked the participants a similar question, like which place looks safe or which place looks less safe. And then the participants need to pick up the image that looks safer or looks less safe. It should be noted that all participants live in Stockholm, and we also recorded their age and gender. Since our study area is only in Stockholm, so this could be treated as a localized survey data. And there is also another popular data called Place Similarity, which measures and collects human 6 dimensions of perceptions, including safe, lively, boring, wealthy, depressing, and beautiful. We think that this dataset reflects people's general perceptual preferences of place at the global scale. So after we collect this data, build this survey to collect some survey data, and then we train a deep learning model to learn perceptual scores. At that time, at that time we use some methods which are state of the art at that time, like DenseNet and ResNet, so that once we complete training, given a specific input trivial image, we can make a prediction of the safety perceptions of that image. So here are some results in Stockholm. As you can see, there are 2 groups of sample images. The top one are those images predicted with high safety scores. And the bottom one are those images predicted with low safety scores. So based on the trivial images as well as their safety perception scores, we created a map on the right to show the safety perceptions across the entire study area, which is Stockholm in Sweden. Yeah, so this is the spatial distributions of our AI-based safety perceptions. And then you may ask, like, after we collect such safety perceptions, after we measure such subjective safety perceptions, what could be the next? What could be the next? As geographers, and I also had training background in urban planning, these safety perception scores have huge practical implications. For instance, like for urban planners, we are curious about what contributes to human safety perceptions. We notice that there are several key factors, such as the high quality of the neighborhood's visual appearance, inner city views, and the prosperous economy, as well as certain types of urban facilities, such as gas stations, might be associated with safety perceptions. We collaborate with the city planning office at the Stockholm. So if we discover this knowledge, this can actually benefit their planning practices to improve the urban design, to improve the placemaking, to better make beautiful neighborhoods. So that's the first implication. And when we talk about safety perceptions, another associated factor is crime. So what is a safe neighborhood? For criminologists and for police, they think a neighborhood is safe means a neighborhood should have less crime, right? We all want to live in a neighborhood that has less crime rate. So we further examine the associations between safety perceptions and crime, and we identified that we built their associations, and we find that generally speaking, these two are positively associated, which means if a location give people safe perceptions, it also has low crime rates. But we also delve into those regions, like these two variables, the safety perceptions and crime are different. We hope to inform the policing practices. So that's what criminologists and police, they are curious about. Third, again, for urban planners, they are also curious about what environmental factors contribute to the safety perceptions and how can we inform and guide urban design. So here I just list several 3D images in different land use types, such as inner city, large scale, and single family housing. And then we examine what objects, what environmental objects contribute to such safety perceptions. And as you can see, their appearance are different, right? And for different land use types, the safety perceptions are also different and the objects are different. So the findings of this paper could better inform the future urban planning practices. As you can see, we leverage large-scale street view images as well as deep learning methods to measure human subjective safety perceptions, which is like the human dimension of places of perceptions of the environment which were overlooked. And by doing so, we can benefit a lot of practical applications ranging from urban planning practices, urban design practices, criminologists, as well as police, right? So it showcases how spatial data science could empower the future placemaking to design safer neighborhoods. So that's my first project. And then let's move to the next project, Geo-contextual Soundscape to landscape generation. As human, when we perceive the environment, what I just mentioned rely on our human eyes, right? Rely on our human eyes. We only focus on the human visual perceptions of the environment. However, as human, we experience the world multi-sensory. We also have our acoustic perceptions. So is it possible that we link the two dimensions together to have a more comprehensive perceptions of the world? So I would like to give you a second example, and I will play two audios. So play two audios. When I play in these two audios, please try to imagine, try to think about the environment of these two audios. So now please close your eyes. I will play with the first audio and try to think about the place. Try to think about the environment. So the first audio. Then the next audio, the second audio. So when you're listening to these two different audios, can you think about the environment that you are? So look at these three images. Anyone could make a guess of which audio is associated with which photo. Yeah, feel free to make a guess. Yeah, cool. Audio one is what? Audio one is A. Yeah, any others? Yeah. C, audio is C, and any others like for audio two? A, yeah. So yeah, as you can see, when we listening to the audios, you can think about the environment, right? You can think about the environment. So as geographers, we are also curious about this question, like how can we understand the two dimensions of perceptions? But traditionally, there is no effective ways to visualize the auditory perceptions, like lack of intuitive ways to effectively and vividly characterize the acoustic environment, especially when compared with those methods for visual perceptions. So this is an image captured by the audience at the stadium for the football games. When you look at this image, you can imagine the sound, right? You can imagine the sound. But how can we analyze the sound? It's not that vivid, it's not that effective, because we may rely on auditory perceptions like the spectrograms, acoustic signal attributes, etc. It's not like the visual perceptions, like we can perform image analysis. And the second challenge or the second motivation is, as human, we experience the world with all senses simultaneously, right? When you visit a location, we will use our eyes and our ears to perceive the environment. But most existing studies focus on just a singular dimension of the human sense of place, while overlooking the complexity and depth of human environment interactions, which are inherently shaped by multisensory experiences. The next challenge is, you might have seen several generation models such as Sora or other like image generation or video generation or text generation models. There is a small string in computer science called audio to image, like which can translate the audio information to images, such as coding, sound to scene, audio token, occlusion, etc. However, we notice that the geographic contexts have been overlooked. For instance, look at the datasets that they are using. Prior studies rely on general datasets while overlook geographic and environmental settings. Like when you play a sound of a vehicle, then the output is a vehicle. When you hear about the bird calls, the output is a bird image. As geographers, we actually don't care about that. When we hear about the bird calls, we want to see the environment, such as those parks, such as those natural parks. When we hear the vehicle horns, we want to see a streetscape. We want to see the business, the busy downtown areas. And another question is regarding the methodology, the DIT, which is a diffusion transformer, which has demonstrated advanced performance, hasn't been used in audio to image models and not to integrate geographic context. And another question, another challenge is for the evaluation. Prior studies may fall short in capturing geographic semantic alignments between the soundscape and images because they rely on some traditional design metrics, such as the FID, to examine whether the two images are similar to each other. However, as geographers, we are more curious about whether the environment of the soundscape and the environment of the image are similar to each other. So here comes to the question, as geographers, can we visualize the place of what we hear? So we propose the geo-contextual soundscape to landscape problem to generate the landscape images from environmental soundscapes guided by an optional scene prompt. So the goal is we want to input the environmental soundscapes such as bird chirping, flowing water, street music, and the output is weird of those soundscapes, such as grassland, shoreline, commercial areas, suburban areas, etc. So to solve this, to support this GeoSQL problem, we first built two large-scale geographic data. The first one is called Sounding SVI, and the second one is the Sonic Urban. So compared with traditional existing audio to image or the audio image pair datasets, we create huge volumes of the dataset, including like 330K audio image pairs and 250K for sounding urban of the image, sounding and image pairs. And all of these two datasets showcase the diverse spatial coverages across the entire world, and also with different geographic environmental settings. For instance, to create the sounding SVI dataset, we collect the data from geotagged soundscape in our domain, and we also collected, based on its location information, we collected its nearby street view images. And on the right, you can see the images that we collected. These are all street view images, which describes the environment of that location, the location of the soundscape. The second dataset is called Sounding Urban, which we downloaded several YouTube videos by searching via keywords such as the city walk in specific locations, such as in Seattle, in different countries, in different regions. And because we downloaded the videos of the city walk, we removed the human voice using some human voice detection models, and then we align the image and the soundscape together to generate this sounding urban dataset. As you can see, so this sounding urban dataset also covers a diverse geographic environment, such as crosswalk, downtown, forest road, etc. After we built these two datasets, two geo-contextual datasets, the next step is we further develop a cutting-edge diffusion model by integrating DIT, which is a state-of-the-art diffusion model. So this sounding DIT could handle multimodality datasets, including the landscape images, soundscape, and environmental soundscapes. And we also provide a scene prompt, which is just a text prompt, such as with some short words such as streets, forest, beach, to better guide the generation process of the image. And we innovatively designed the SounDIT block, which leverage TAP MOE, which combine multiple experts to fuse these three modalities together to generate the high quality landscape images. And it should be noted that at the inference level, we also enable a geo-contextual RAG process to retrieve some nearby geographic information. Because sometimes when geographers collect the environmental data, we may have some additional text, additional geographic information, such as the spatial layout or the coordinates. And if we can input this geographic information into the model, it may improve the quality of the image generated. Third, as I mentioned, prior studies usually leverage some existing evaluation matrix, such as the FID. However, as geographers, we are curious about the environmental settings, the geographic location characteristics of the input soundscapes and the output landscapes. So we have the hypothesis that the soundscapes and the landscapes are expected to share similar environmental and geographic characteristics and place settings. So inspired by several common practices in geography and in urban planning, we propose a new geo-contextual evaluation framework consisting these three levels, including the element level, scene level, and human perception level. So we designed these three evaluation levels. These are all informed by practices in urban planning. The element refers to those individual objects, such as trees, buildings, roads, that consist of those environmental objects in the street view images. Scene level refers to the category of the location. For instance, if you hear a soundscape in park, we hope that the generated image should also be a park image, right? And if, for instance, when you're hearing the sound of the oceans or the beach, those water flows, we also expect a similar place scenes generated in the outcome image. The last one refers to the human perception levels. Like when we look at that specific image, we hope people have similar perceptions. Like if I collect a soundscape in a safe neighborhood, in a neighborhood that makes you feel safe, then we expect the generated image should also evoke a similar safety perception. So by designing these 3 levels of place similarity score, we provide such a geo-contextual evaluation framework informed by urban planning practices to comprehensively evaluate the results of and the quality of the generated images. So here are some examples of the place similarity score at different levels. Like for element, as you can see, if two images, if they have high scores, then this indicates their elements are similar. Like they all have high proportions of building, sky, trees, etc. Otherwise, as you can see, like this, their elements are totally different. Well, for things, if they have high place similarity scores at scene level, then the categories are similar, such as these 2 locations are all at the street. Well, if they are low score, then this indicates the categories are totally different. The perception refers to like whether the location, whether the image generated evoke you similar perceptions, like the safety perception, like when you look at the input image and the output image, whether you have similar human perceptions, like whether it makes you feel safe or not safe. So by doing so, we can comprehensively evaluate the generated images. So here are the results of our generated image compared with prior studies, compared with prior models. For instance, if you look at our SounDiT model, compare our SounDiT model with the ground truth, and if you compare this with the previous models, you can feel the images generated have a similar environmental settings, have a similar geographic settings of the ground truth, right? But if you look at some other examples like here, like this column, this is obviously something that we do not want as geographers, because we might be not that interested in these specific animals or specific cars, but we are curious about the geography, the environmental settings of that image. And we also run some matrix, including the FID and our place similarity scores. And the results show that our methods consistently outperform the previous methods in both FID as well as the place similarity scores. To comprehensively evaluate the results, we also invite people to run a user study, such as select the image that you believe are most closely related to the audio clip and choose the one generated landscape that best matches the ground truth. So by doing so, we can comprehensively review and to measure the performance of our SounDiT model. So as you can see, so by doing so, we successfully link the 2 dimensions of human perceptions, including the auditory perceptions as well as your visual perceptions. By doing so, like it's possible to visualize what we hear, right? To what we hear, the place, the environment, from what we hear to what we see. So that's the 2 projects. And at the end of this presentation, I just want to briefly talk about a few points, a few takeaways. So first, as you all know that now the advanced AI as well as data science methods provide novel opportunities to advance knowledge of human experience at place and also in geography and other different domains, not only in computer science, not only in data science, these domains, but it can empower other domains, a lot of domains. You might come with different backgrounds or even diverse backgrounds, such as public health, transportation, and other domains. I believe advanced AI methods could benefit to advance the knowledge in different domains if you can identify the correct question. However, domain knowledge, for instance, for me as a geographer, I would like to integrate geographic principles and theories. They are still essential in enriching the current geospatial data science and AI. For instance, back to my case of the soundscape to image generation, audio to image models have been used in computer science, have been developed in computer science, but there is still a gap to implement, to apply them in geography. And we integrate the audio to image this stream by building the large-scale geographic datasets, by building the cutting-edge models, the SounDiT model to integrate geographic knowledge, and also to design practical informed evaluation matrix following the common planning practices. So it's still necessary to integrate domain knowledge in enriching the data science and AI methods. If you are coming from different domains, as I mentioned, your domain knowledge are still very valuable to better inform and design more powerful AI methods. Finally, as you can see, my work is about human perceptions, like the safety perceptions, the multi-sensory experiences, multi-sensory perceptions. So in the future, perception is related to human, like the psychological effects. So more psychological and neuroscience methods might be integrated to better examining human environmental relationships. So that's all for my presentation today. It's really my